Well, welcome. This screencast is meant to talk with elementary educators about some models that we use for multiplying integers. As with adding integers and subtracting integers, we will use as our first model the chip model. And we'll try to make some meaning out of what it means to say +2 times +3. What does that mean? Well, first of all, we want to make sure that we get the same answer that we get when we use the area model that we used for whole numbers. 2 times 3 is definitely 6. So what we're going to say in this case is that when we multiply integers, this tells us that we're putting in two groups of 3. Into the play area, we want to put in, because this is positive, two groups of whatever this is. So we put in one group of 3, and then we put in another group of 3, and we ask what's in the play area, and what's in the play area, 2 times 3 is 6, and we say, okay, maybe this model works because we got the same answer that we got when we did whole numbers. But does that work when we say put in two groups of -3? Well, it seems like yes, we can put in a group of -3 and then a second group of -3, and then we ask what's in the play area, and in the play area is -6. 2 times -3 is -6. And that builds some understanding. We know that a positive times a negative is a negative, and this shows how that is consistent. So then the question becomes, what happens when we want to do -2 times 3? What meaning does that have? Well, this says take away two groups of 3. And so now you're at a loss because you have to take away two groups of 3, but there aren't any groups of 3 anyway. So we ask ourselves, could we make 0 pairs? Could we put 0 pairs into the mix? And that answer, of course, is yes. You got a 0 pair, and then you can just make a bunch of 0 pairs. And so sure enough, you've got 6 0 pairs. But now, I'm going to need to ungroup all of these. But now, we can take away two groups of 3. We can take away this group of 3. We can take away this group of 3. These go away, and these go away. And what's left in the play area, -2 times 3, is -6. So when we have a -2 times a +3, we can add 0 pairs so that we're able to take away the thing we need to take away. The other model we'll use is the number line model. And the number line model runs the way you think it does. You have some number line, and we pretend that we want to do, I don't know, let's do 2 times 3. Well, what does that mean? That means that starting from 0, we face right, we face the positive end of the number line because the 2 is positive, and then we make 2 jumps of 3. And what did 3 mean? Well, that's positive 3, and in our number line model, positive 3 means forward 3. So we make 2 jumps forward 3. And so 2 times 3 is in fact 6. Whereas if we were to make 2 jumps of negative 3, what would it mean to make 2 jumps of negative 3? Well, to make 2 jumps of negative 3, in our number line model, this second number, this negative 3, means go backward 3. If we're facing the positive end of the number line, but we're jumping backwards, 2 times negative 3 is negative 6. And this sort of thing is consistent with our previous work with the number line model. The interesting and difficult part comes when we consider negative 2 times 3. So negative 2 times 3 is the opposite of positive 2 times 3. So what does opposite mean? Well, in positive 2 times 3, we faced the right. We faced the positive end of the number line. In negative 2 times 3, we face the negative end of the number line. And we make 2 jumps forward 3. Forward while we're looking at the negative end of the number line. 2 jumps forward 3. Negative 2 times positive 3 is negative 6. By the way, by the commutative property, we should get the same answer if we do 3 jumps of negative 2, facing the positive end of the number line, jumping backwards 3 times by 2 apiece, should get us to the same place. Negative 2 times 3 is negative 6. Take some time. Make sure that you can do models. Make sure you can model those. Answers coming soon. Told you answers were coming soon. Hopefully you went 3 for 3 and didn't need a calculator. Thanks, everybody.